Hello everybody, I hope you can see the presentation. My name is Molnár and I start the weather situation analysis. So first of all, if you allow me, I would like to say a few words about myself. I've been working at the Hungarian Meteorological Service as a weather forecaster from 2017, and after a few years ago, a social media team was created, of which I am a member. I've been lucky enough to participate in 2 EUMeTrain courses so far, which took place in Thessaloniki and Sarajevo. So that's all about me. Now this is your turn. Where are you from? Please tag on the map where you follow the briefing. I think now you can do it. And as you can see, we log in from Hungary, Budapest. Okay, thank you for your feedback, and let's move on the weather situation analysis. To tell the truth, the actual weather situation in Europe is not very exciting, but let's look over together what can we see. First of all, take a look at the Airmass RGB. What information does it provide us? The colors help to understand properties of the Airmass. With a bluish-purple color, which mainly dominates in the northern part of Europe, it means it's colder air, while the greenish shade, which is more visible on the south, refers to warm tropical air. And the reddish color gives information about the drier, mainly stratospheric origin air. There are a lot of clouds over most parts of Europe because fronts arrive with westerly flow, along which the clouds are thicker. Meanwhile, an anticyclone is stretching in from southwest. And if we put the 500 hectopascal geopotential on the Airmass image, we get a picture of troughs and ridges. In the western part of our continent and over Eastern Europe, there are troughs, and a cold vortex has formed on the southern part of the eastern one. In the axis of the troughs and in the cold vortex, we can observe reddish dry air, as you can see it. And between the two, there is a ridge, so the weather there is calmer, and as I have already mentioned, anticyclonic effects prevail near the surface. The position of the troughs and ridges can also be seen on the water vapor satellite image, as well as the cold vortex over Italy. What was reddish in the Airmass RGB, now in the water vapor image, it is more darker. So it is also show us that in the higher level, the air is dry. And now take a look at the altitude flow. As we have seen on the Airmass RGB, currently there is no significant Airmass boundary on our continent. And as you can see, mainly over northern and western part of Europe can be observed jet over Scandinavia and over the Atlantic Ocean. The weaker fronts don't cause significant precipitation either. This can also be seen by looking at the precipitation map of the last 24 hours. Precipitation occurred only along the fronts and the cold vortex, but significant amounts fell in only a few places. With the help of the natural composite satellite image, we can already get an idea of the moisture content of the lower levels. and in the case of clear skies, of the vegetation and also the snow cover. In the area of the anticyclone, in some places stratus, mist and fog formed at night, but due to the strong sunshine, most of it dissipates during the day. There are also a couple of interesting things here. The turquoise color informs us not just about the ice clouds, but also about the snow cover. And based on this, it can be said that extensive snow cover can only be observed in a few places in Europe, usually only in the mountains. And in addition, it is also worth talking about the vegetation, because the condition of the surface is visible in the cloudless areas. Greener shades gives information about while brown about drier soil condition. And the last satellite image I want to show you is the 24-hour microphysical satellite image. Thicker frontal clouds are clearly visible here as well, which are marked with dark red. And the medium and low-level cloud color is yellowish. And if we are very attentive, we can see something else. The cyclone over Africa has picked up some dust, which appears in the satellite image with a pink shade. The thick reddish clouds cover most of it, but the pinkish color is still visible in smaller parts. And contrails are visible in the region of Spain, but it was even more visible on yesterday's satellite image. The linear structure can be observed in the cirrus clouds, and they are marked with dark blue. And for your interest, I have brought a European temperature anomaly map, which shows that mild air will dominate over most of our continent during the week. The original situation will not change significantly. A low pressure system will continue to exist in the northwest, which sometimes transport cooler air over the southern parts of the continent. But as you can see, we will still have much warmer weather than the average across the continent. But the pattern maybe will change in the next week. And this was my part. Thank you for your attention. And now my colleague Zsanett will continue the briefing. Thank you again and bye.
Hello everybody. I will continue the briefing. Are you ready? My name is Zsanett Szabó, and I have been working at the Hungarian Meteorological Service for 6 years as well. I mainly do nowcasting and warning forecast, but I do short and medium range forecasts as well as ANNA. I am also a member of our interactive media team. I have attended at the CEMET course as well in Sarajevo in 2019, where maybe I could meet with some of you. But let's start with the case study, which is special for me because it was a situation in which I was the warning forecaster. And it was also my first case where I issued a red warning. Based on the rhyme, you can probably already guess what it will be about. Let's get down to business and let's start with a task. This is an Airmass RGB satellite image for the 3rd of February. Airmass RGB is mainly used for the analysis of atmospheric dynamic processes, for example, to detect cyclogenesis or to separate polar and tropical air masses. And it can also be used to identify jet streams. And the task is the following. Label the following: the low and high pressure zones and the jet. Okay, thank you very much. Thank you for the answers. You are very skillful, as you marked the low pressure zone is located in the northern part of Europe, as the thick cloud system of the frontal system shows as well. Over there, cold and dry air mass fills out the area, which is marked by the red and blue colors. The high pressure can be seen at the Mediterranean area, where the green color dominates, which indicates the warmer air mass. Many of you also guessed the location of the jet, but we will return to this later. High and low pressure can also be identified on the night Microphysics RGB satellite image. With the help of this fog and low-level clouds can be detected at night, which now clearly visible in the area of high pressure over southwestern Europe, especially in France, where it can be seen with yellow color. The red color indicates the thick ice cloud of the frontal system. As a point of interest, I would like to note that to the northwest of Hungary, cumulonimbus clouds started to develop, and their color is slightly different. It has a reddish-brown base with greenish-yellow dots, which means that the clouds are already very cold. Between approximately 5:30 a.m. and 7 a.m. local time, it produced thunderstorms. Now turn our attention to the jet, as this will be the point for us. On the Airmass RGB, the location of the jet axis is indicated by the sharp transition between the blue and the red areas. And the actual location can also be seen in the following picture. So we can see the position of the jet now. This is an infrared image, and the wind of the 300 hectopascal level is also can be seen. We can tell that the jet stretched through Hungary with a perpendicular axis. By now, you can probably guess that the jet stream has a main role in terms of this case study. Due to this and to other processes, huge damaging wind has improved in Hungary. Let's look at the details. In the following pictures, we can see the equivalent potential temperature and the synoptic situation at the 850 hectopascal level. The circumstances of the storm were relatively unusual. In this case, before the arrival of the storm, a so-called north-south flow channel already existed, which was formed in the common flow system of the huge anticyclone in the west and the cyclone in the northeast part of our continent. On the northern edge of the anticyclone, smaller-sized air vortex started from west to east. And when it reached the north-south flow channel, it turned to the southeast and began to deepen very quickly, creating a large air pressure difference. The large temperature difference also contributed to the pressure changes, which further fueled the cyclone. Then a strong cold inflow began to form the northeast. Dry, cold air mass broke in the country. Overall, the windstorm was created through the combined effect of these elements. Take a look at the front analysis. First, the warm front, then, on the dawn of February the 4th, the cold front of the cyclone's front system reached the country. On the front analysis map, we can see the February 4th 0 UTC situation prepared by our colleagues. The thickening isobar lines are already visible here, indicating the form of the windstorm. The 72-hour maximum wind map also shows the mentioned north-south flow channel that developed days earlier. And you can see the windstorm occurred in other parts of our continent as well due to the vortex. And the development and progress can be clearly traced on it. The darker the shades, the stronger the wind gusts. The color red, for example, indicates the stormy category, while bluish-purple shades indicate gale force or orkan force wind gusts. The following image on the left is a 24-hour maximum wind speed map with the strongest measured wind gusts. Stormy gusts develop in most of the country. In Transdanubia, gale force On the mountains, almost orkan force wind gusts occurred during the day. In the eastern part of the country, there were also gale force gusts. These were the tailwinds of intense rain showers. In addition, you can see the warning forecast for that day. In our warning system, there are three levels for dangerous wind gusts. The first, lowest level, is the yellow, second is the orange, and red means the highest level in our system. It indicates that the expected gusts may exceed 110 km per hour. Based on the coloring and the measured values, it can be seen that the coloring was appropriate. The warning forecast is available to anyone, but in case of a red alert, we also send a message to the authorities and the governmental institutions. The information reaches the disaster management and the media as soon as possible. In the week before the event, we gradually built up the communication of the situation on our social media platforms. The pictures show two posts from that day. In our posts, we not only convey the basic information about the weather, but we also try to introduce and understand the background of the given situation to the users. The picture in the lower left corner shows the measured air pressure taken from that day. This shows that there was an unusually large west-east pressure difference, which is uncommon for the size of this country. In the upper right corner, you can see one of our daily posts called "What Should We Pay Attention Today?" This post is usually edited by the social media colleague who is on duty. Finally, some pictures about the damage caused by the wind. Due to the windstorm, many reports were received by the disaster management, and the firefighters also worked non-stop. There was no point in the country that wasn't affected by the strong wind. The stormy weather gave the most work in the southwestern parts. The windstorm broke tree branches in many places and felled the trees. The fallen trees caused damage even in the well-built environment. And that's all for today. Thank you for your attention. Goodbye.
Okay, thank you very much, Anna and Zsanett, for your presentation. I'm wondering if there is anybody that has any questions. You can write it in your chat or turn on your microphone and ask.
Hi there, Ivan speaking. Can you hear me?
Yes, I can hear you.
Okay, I think Anna was showing imagery from today, and two things
Yes.
that I noticed very nicely seen. You nicely show the difference, actually the similarity between the snow and the ice clouds in the color of natural color RGB. There was a nice thing to notice in the Bay of Botany, just between Finland and Sweden, the northern tip. I think it was frozen. If you would go back to the natural color RGB, I think it was cyan. At the last moment, I spotted that. Okay, there is a cyan color, and I think this is probably frozen sea. I'm not sure about that, but likely because anything that is cyan color is ice, actually frozen water. So be it in the ice or a lake or ice crystal in the clouds, I think it's the same color, similar at least. And the other thing was just towards the south, over the southern Mediterranean, I guess offshore Libya, there is a big dust-infused cloud. And if any of you consult, for instance, convection RGB, he or she would see that this cloud is very yellow, meaning it consists of very small ice particles due to, maybe you have it somewhere. Oh, but also if you go back to, yeah, you have the dust RGB, exactly. So this cloud just coming from the North Africa towards the, Greece mostly, direction of Greece. If you look at any of the RGBs that can tell you about the microphysics, like convection RGB or day microphysics RGB, you would see this cloud in a very bright yellow or orange colors. This is due to the fact when dust is infused into the cloud, it changes microphysics and the ice particle becoming very small. The other thing is interesting for these so-called DIPS cloud, dust-infused Berkeley cloud systems, is that they tend to be very high, and the height kind of can be seen from even from the Airmass RGB. If you would go back to the Airmass RGB, this cloud would be likely very bright white. Yeah. So yeah, exactly. So you see the difference between some frontal clouds here over the France and the British Isles, and this very bright white cloud over Mediterranean. So when you see very bright cloud system on the synoptic scale, likely it's dust infused cloud or a mountain wave cloud, which both clouds are, for instance, very high reaching clouds. So that's just a comment from my side.
Okay, thank you very much.
Thank you for the very nice presentation.
You're welcome. Thank you for your attention, and thank you for the explanation.
Okay, if there is any other question, please pose it. We have one question from our professor at college, Branko. Do you know how large waves were on the Lake of Balaton? How high were they?
I think we have no information about, but our colleagues who work on Siófok at Lake Balaton, maybe they can tell us that what high was the waves, but no, we have no information about this, but we know that very well that on that day it was very windy and the waves were greater than usual, of course.
Okay, thanks everybody for your attention. Thanks to Anna and Zsanett. I am inviting everybody for the next weather briefing, which will be held on 25th next month by our colleagues from ZAMK. So have a nice day and goodbye.
Goodbye.